Draw the energy band diagram of N-type and P-type semiconductors at a temperature T greater than 0 Kelvin. In the case of N-type semiconductor, the donor energy level is slightly below the bottom of the conduction band, wherein P-type semiconductor, the acceptor energy level is slightly above the top of the valence band. Explain, giving example. What role do this energy level play in conduction and valence bands? Okay, we'll see the diagram of the band diagram, energy band diagram. This is the energy band diagram of N-type and P-type semiconductors. If you observe this one, how to identify which is the N-type and which is the P-type? Okay, this is, I can say this is the N-type semiconductor, N-type, and the second one is the P-type semiconductor. How best we can identify? Okay, in the N-type semiconductors, if you observe here, the number of holes is less and the number of electrons are more in the N-type semiconductor. But in case of P-type semiconductors, the number of holes are more and the number of electrons are very less in the P-type semiconductor. This is one method to identify which is the N and P-type semiconductors. Okay, and the donor energy level decreases the energy gap between the conduction band and valence band. As a result, the conduction band will get more electrons from the donor impurity with very small supply of energy. See, this is the ED, that is the impurity, and the energy, that is the donor energy. Okay. From this, we'll get more electrons from the donor impurity with very small supply of energy. Whereas in P-type semiconductor, the holes from the acceptor, this is EA, that is the acceptor energy. The holes from the acceptor level sinks down into the valence band.